Class, today we will study the cranial nerves. First, we will learn about the oculomotor nerve, trochlear nerve, and abducens nerve. Cranial nerves also belong to the peripheral nervous system. They connect the brain to the receptors and effectors of the head, neck, and thoracic and abdominal organs. There are 12 pairs of cranial nerves: I olfactory, 2 optic, 3 oculomotor. For trochlear, V trigeminal, 6 abducent, 7 facial, 8 vestibulocochlear, 9 glossopharyngeal, X vagus, 11 accessory, 12 hypoglossal. The fiber components of cranial nerves are more complex than those of spinal nerves. Based primarily on characteristics such as embryonic origin and function, they are classified into 7 types of fiber components. 1. General somatic sensory fibers, distributed to the skin, muscles, tendons, and most of the mucosa of the mouth and nose within the orbit. 2. Special somatic sensory fibers, distributed to the special sense organs derived from ectoderm, namely the visual apparatus and the vestibulocochlear organ. 3. General visceral sensory fibers, distributed to the viscera of the head, neck, thorax, and abdomen. 4. Special visceral sensory fibers, distributed to the taste buds and olfactory organ. Although these receptors are derived from ectoderm, they are related to visceral functions such as eating. Hence, the fibers connected to them are called special visceral sensory fibers. 5. General somatic motor fibers, distributed to striated muscles derived from mesoderm, such as the extraocular muscles and the muscles of the tongue. 6. General visceral motor fibers, distributed to smooth muscle, cardiac muscle, and glands. 7. Special visceral motor fibers, distributed to the masticatory muscles, facial expression muscles, pharyngeal muscles, etc. Although these muscles are all striated, they are derived from the branchial arches, which are closely related to the anterior end of the digestive tube. Therefore, the nerve fibers distributed to these striated muscles are called special visceral motor fibers. Sensory nerves, olfactory, optic, and vestibulocochlear nerves. Motor nerves include the oculomotor, trochlear, abducent, accessory, and hypoglossal nerves. Mixed nerves include the trigeminal, facial, glossopharyngeal, and vagus nerves. First, let's look at the oculomotor nerve. The oculomotor nerve is a motor nerve. It contains 2 types of fibers: general somatic motor and general visceral motor fibers. The general somatic motor fibers arise from the oculomotor nucleus at the level of the superior colliculus of the midbrain. The general visceral motor fibers arise from the accessory oculomotor nucleus, Edinger-Westphal nucleus, of the midbrain. After the 2 types of fibers merge to form the oculomotor nerve, it exits the brain from the interpeduncular fossa on the ventral side of the midbrain. It passes forward closely along the edge of the tentorial notch and the anterior surface of the posterior clinoid process of the sella turcica. It travels through the superior part of the lateral wall of the cavernous sinus. It then enters the orbit through the superior orbital fissure. It divides into superior and inferior branches. The smaller superior branch distributes to the levator palpebrae superioris and superior rectus muscles. The larger inferior branch distributes to the inferior rectus, medial rectus, and inferior oblique muscles. The visceral motor, parasympathetic, fibers within the oculomotor nerve separate individually as a small branch from the inferior oblique muscle branch, called the short root of the ciliary ganglion. They enter the ciliary ganglion to synapse. Postganglionic fibers enter the eyeball to distribute to the ciliary muscle and sphincter pupillae muscle. They participate in the accommodation reflex and the pupillary light reflex. Injury to the oculomotor nerve can cause paralysis of the levator palpebrae superioris, superior rectus, medial rectus, inferior rectus, and inferior oblique muscles. Symptoms include ptosis, pupil deviated downward and outward, mydriasis, pupil dilation, and loss of the light reflex. Next, let's look at the trochlear nerve. The trochlear nerve is a motor cranial nerve. It arises from the trochlear nucleus at the level of the inferior colliculus of the midbrain, contralateral. It exits the brain dorsally from below the inferior colliculus of the midbrain. It is the thinnest of the cranial nerves. After emerging from the brain, it winds around the lateral side of the cerebral peduncle to pass forward. It also passes through the lateral wall of the cavernous sinus. It moves forward and enters the orbit through the superior orbital fissure. It passes over the superior rectus and levator palpebrae superioris muscles and runs anteromedially. It enters and supplies the superior oblique muscle. The abducens nerve is a somatic motor nerve. It arises from the abducent nucleus in the pons. Its fibers go ventrally and exit the brain at the pontomedullary junction, on either side of the midline. It proceeds forward to the apex of the petrous part of the temporal bone, where it pierces and enters the cavernous sinus. Within the sinus, it runs forward along the infralateral side of the internal carotid artery. It enters the orbit through the superior orbital fissure and distributes to the lateral rectus muscle. Injury to the abducens nerve can cause paralysis of the lateral rectus muscle, resulting in esotropia, internal strabismus. Class, in this session we have learned about several of the 12 pairs of cranial nerves. Next, we will proceed to study the following nerves.